Okay, let's look at the graph of cosine. We have cosine of 0 is equal to 1. So the first point on our graph, when x, the angle, is 0, we have cosine of 0 equals 1. So the point 0, 1 is on the graph. Now, as x, the angle, increases, the terminal ray of that angle swings around the unit circle, and we're going to see what happens as it swings around from 0 to 2 pi. In the first quadrant, the cosine, which is the first coordinate of this point, or is the distance of this point from the positive y-axis. This is a positive number, and it gradually decreases as the point moves towards the y-axis, and it hits 0 at pi over 2. So over that first quarter revolution, the cosine, as x increases from 0 to 2 pi, the cosine decreases from 1 to 0. Now, as the terminal ray of the angle moves into the second quadrant, the cosine, which is the first coordinate of this point, becomes negative. And its absolute value is the distance of the point from the positive y-axis, but that's a negative number, and the distance increases. But because it's negative, the number itself is decreasing, and gradually it decreases until it hits -1 for the straight angle pi. And right over here at the straight angle pi, cosine of pi is -1. And then as we move into the third quadrant, the cosine is still negative, but this point is getting closer to the y-axis again, so the distance between the y-axis and the point is decreasing, and therefore the absolute value of these negative numbers is decreasing. So when you put all of that together, you get that these negative numbers gradually increase, and they hit 0 when x, the angle, is 3 pi over 2. And then over this last quadrant, we have that the cosine is positive again. Again, it measures the distance of the point from the y-axis, so that distance gradually increases from 0 to 1. And it hits 1 at the angle x equals 2 pi. So this gives us a picture of the cosine function, cosine of x, where x is an angle measured in radians, between 0 and 2 pi. And we saw that that's enough to derive the entire function, to the graph of the entire function y equals cosine of x, because this function repeats this wave on every subsequent interval of length 2 pi, and also on every previous interval of length 2 pi. So we can extend our information to get the full graph of y equals cosine of x. And again, it's a wave function, but this time the wave starts at the crest of the wave above the origin, and this wave repeats itself on every interval from 0 to 2 pi.